Explorer 1 and Explorer 2 were no common space apparatuses. They were fastidiously planned with vigorous designs and a revolution rate in excess of multiple times slower than the hour hand of a clock. This configuration minimized visible blurring, permitting the spacecraft to capture pictures and data simultaneously while traveling through space. Even before their encounters with the outer planets, their remarkable imaging abilities began to intrigue scientists and the public alike. The rocket started transmitting images of Jupiter a few months before completing its main mission. These early pictures, showcasing swirling clouds and the iconic Great Red Spot, captivated audiences at NASA's Jet Propulsion Laboratory. However, it was the discovery of active volcanoes on Jupiter's moon Io that truly took the spotlight. Io, slightly larger than Earth's moon, turned out to be the most volcanically active body in our solar system. The rocket's instruments detected continuous signals from Io, which were confirmed by the brilliant images it captured, revealing towering volcanic plumes and a surface scarred by volcanic material ejections. One of Io's most prominent volcanoes, Pele, erupted with a force many times greater than Mount Everest, covering an area nearly the size of France. As the spacecraft's cameras eventually shut down to conserve energy and memory before their journey into the interstellar region, it's worth noting that the images they captured did not include Mercury and Mars for various reasons. Nonetheless, in addition to Explorer 1 and Explorer 2, NASA has also operated other remarkable spacecraft such as Pioneer 10, Pioneer 11, and New Horizons. On February 17, 1998, Explorer 1 surpassed Pioneer 10, marking the moment when Pioneer 10 became the most distant spacecraft. Explorer 1 continued its solitary journey for another 14 years before entering the interstellar medium on August 25, 2012. Although no other exceptional space probes were in sight to follow, NASA did not publicly announce this significant achievement until 2013. The tension arises due to gravitational lensing surveys suggesting a lower value of S8 than expected by the standard cosmological model based on cosmic microwave background, CMB, data. Efforts to resolve the S8 tension have led scientists to explore various hypotheses, ranging from potential systematic errors in the data to fundamental changes in our understanding of gravity. Contemporary simulations, including the Flamingo project, have played a crucial role in providing insights into the complex interplay between dark matter and gravitational forces in shaping the cosmic web. Despite the challenges posed by the S8 tension, many measurements taken at low redshifts and from the CMB remain consistent with the standard cosmological model. This has led to the exciting possibility that the universe may have experienced a significant evolution in its development, challenging our current understanding of cosmic structure and evolution. In summary, the S8 tension represents a major challenge to our understanding of cosmological structure and may require updates to current theoretical frameworks. Explorer 1 continues its extraordinary journey through space, steadfastly sending back valuable records from the farthest reaches of the universe. For nearly 50 years, this remarkable spacecraft has reshaped our understanding of space. However, recently, Explorer 1 has begun transmitting troubling data to Earth, leaving the entire space organization in shock. Are these unsettling measurements the result of a technical malfunction, or could they be signals from extraterrestrial sources? Join us as we uncover the truth behind these astounding transmissions. Since prehistoric times, scientists have been fascinated by the mysteries that lie beyond our celestial boundaries. This curiosity led to the historic launch of the Explorer 1 and Explorer 2 spacecraft, among other notable space missions. These pioneering missions, celebrated for their achievements, began with the launch of Explorer 2 from NASA's Kennedy Space Center on August 21, 1977. A few weeks later, on September 5th of that same year, Explorer 1 was launched. These twin probes, each weighing about 7,120 kilograms, equivalent to a small car, were sent into space during a specific alignment of the outer planets, setting them on their extraordinary journey. The explorers navigated different trajectories and speeds, culminating in a critical moment on December 15, 1977, when Explorer 1 overtook its twin. Since then, Explorer 1 has become an invaluable tool, providing extensive data and unraveling space-related mysteries. Before delving into Explorer's latest startling discovery, which has fundamentally shocked the entire space agency, let's take a look at the remarkable images captured by the spacecraft during its groundbreaking Jovian imaging mission in 1978. Explorer 1 was positioned approximately 265 million kilometers from Earth. From this vantage point, it transmitted a diverse array of images back to Earth. In January 1979, the spacecraft embarked on an extraordinary 100-hour mission, capturing time-lapse films depicting 10 revolutions of Jupiter. A treasure trove of 3,750 snapshots allowed us to observe Jupiter's majestic movements in vivid detail. Soon, Explorer 1 ventured through the Jovian moon system and made a remarkable discovery: a small ring around Jupiter and new moons Thebe and Amalthea. This expanded our understanding of Jupiter's intriguing space. To ensure a safe journey and prevent a potential collision with Titan, one of Saturn's moons, corrective maneuvers were performed. Explorer 1 continued its celestial journey around Saturn, revealing 4 more moons: Mimas and Enceladus, Tethys and Rhea. With the completion of the Saturn mission, scientists decided to conclude the Explorer planetary mission, moving both Explorer 1 and Explorer 2 beyond the boundaries of our solar system, speeding through space at an unprecedented rate of 325 million miles per year. In January 1990, a new chapter began, the Explorer interstellar mission. During this phase, Explorer 1 captured some of the most iconic images in history, immortalizing the solar system and most of the planets. One individual who played a crucial role in extending the missions beyond their initial objectives was the distinguished astronomer Carl Sagan. As a member of the Explorer imaging team, Sagan passionately advocated for one final set of images as a farewell gift to humanity. Against all odds, his unwavering dedication succeeded. On February 14, 1990, Explorer 1, positioned 6 billion kilometers from Earth, embarked on a visual journey, capturing what became known as the pale blue dot image. These stunning snapshots, totaling 60 in number, were added to the spacecraft's impressive collection of 670 images during its encounter with Neptune. Explorer 2 achieved a remarkable feat by recording wind speeds exceeding 1,000 meters per second, the fastest winds ever documented within our solar system. As the spacecraft ventured 298 kilometers into Neptune's azure methane atmosphere, it provided invaluable insights into this distant celestial body. Neptune's largest moon, Triton, was revealed as one of the coldest places in our solar system, with surface temperatures plunging to incredibly low levels. Triton also exhibited unique features, including nitrogen gas-spewing ice volcanoes that ejected icy debris 5 miles into its tenuous atmosphere. These extraordinary discoveries expanded our knowledge of the diverse and complex celestial objects residing in the farthest reaches of our solar system. Don't go away. Explorer 1 has recently made one of its most alarming discoveries yet. But first, let's review its accomplishments over the past few decades. The achievements of the Explorer twin probes have been nothing short of extraordinary. Their early observations of Jupiter and Saturn's moons left researchers in awe and challenged previous assumptions about these distant worlds. Moons once thought to be dormant and barren, like our moon, were found to be teeming with geological activity. Explorer 2, in particular, achieved several remarkable milestones during its journey. It made history in 1986 as the first spacecraft to fly by Uranus, and just 3 years later, achieved another historic feat with a flyby of Neptune. To this day, it remains the only spacecraft to have undertaken such missions. As the Explorer spacecraft continued their journey, NASA implemented various measures to extend their operational lifespan. Over the past 3 years, unnecessary components and heaters have been deactivated to conserve power, ensuring that these brave pioneers can continue their mission well into the next decade, with an expected project end date set for 2030. For the scientists and engineers who have been involved from the beginning, the Explorer missions represent both a moment of pride and a deep sense of nostalgia. Their unwavering determination and passionate efforts have surpassed initial expectations. The wealth of data provided by the Explorers has offered valuable insights, fueled numerous scientific discoveries, and inspired countless artists and space enthusiasts. Explorer 1 and Explorer 2 were not ordinary spacecraft. They were meticulously designed with powerful structures and a rotation rate more than 10,000 times slower than the hour hand of a clock. This design minimized visible blurring, allowing the spacecraft to capture images and data simultaneously while traveling through space. Even before their encounters with the outer planets, their extraordinary imaging capabilities began to impress scientists and the public alike. The spacecraft started transmitting images of Jupiter several months before completing its mission. These early images, showcasing swirling clouds and the iconic Great Red Spot, captivated audiences at NASA's Jet Propulsion Laboratory. However, it was the discovery of active volcanoes on Jupiter's moon Io that truly stole the spotlight. Io, slightly larger than Earth's moon, turned out to be the most volcanically active body in our solar system. The rocket's instruments detected continuous signals from Io, which were confirmed by the brilliant images it captured, revealing towering volcanic plumes and a surface scarred by volcanic material ejections. One of Io's most prominent volcanoes, Pele, erupted with a force many times greater than Mount Everest, covering an area nearly the size of France. As the spacecraft's cameras eventually powered down to conserve energy and memory before their journey into the interstellar region, it's worth noting that the images they captured did not include Mercury and Mars for various reasons. Nonetheless, in addition to Explorer 1 and Explorer 2, NASA has also operated other remarkable spacecraft such as Pioneer 10, Pioneer 11, and New Horizons. On February 17, 1998, Explorer 1 surpassed Pioneer 10, marking the moment when Pioneer 10 became the most distant spacecraft. Explorer 1 continued its solitary journey for another 14 years before entering the interstellar medium on August 25, 2012. Although no other exceptional space probes were in sight to follow, NASA did not publicly announce this significant achievement until 2013. In recent years, the explorers have encountered various challenges and limitations. Despite their achievements, technical malfunctions, age-related wear, and dwindling power reserves have begun to take their toll. Yet, these spacecraft continue to persevere, sending back data from the far reaches of our solar system. It's a testament to the ingenuity and dedication of the scientists and engineers who designed and managed these missions. Their contributions have enriched our understanding of the cosmos, and the legacy of the Explorer missions will continue to inspire future generations of space explorers.